Mhm.
Okay, now we are live.
Sajjan is not going to join today. I already had a call.
Is he going to join tomorrow? Do you know?
No, no. Uh, Probably
Not giving exams?
yes or no. Sorry?
What exam? Is he not giving exams?
He is giving an exam, but he got upset after looking at
Tell him,
last paper.
tell him just one subject. Don't screw other subjects because of that. You may get passed in the other subject and just reappear for that one. At least
Yeah,
appear for the exam. No, there's no harm in appearing for the exam.
I told him. I told him.
Yeah. See if he changes his mind. Anyways,
Yeah,
you know how hard it is to like reappear. If he's getting an opportunity to appear, why not just appear and see?
yeah, yeah. Actually. Okay.
Okay.
The space complexity. The space needed by an algorithm is equal to the sum of following two components. A fixed part, a space required to store certain data and variables, that is simple variables, constants, program size, etc., that are not dependent on the size of the program.
Mm-hmm.
A variable part, a space required by a variable whose size is totally dependent on the size of the problem. For example, recursion stack space, dynamic memory allocation, etc.
Mm.
The space complexity S of P of the P algorithm is S of P is equals to A plus SP of I, where A is treated as the fixed part and S of I is treated as the variable part of the algorithm, which depends on instance characteristics I. Following is a
Mm.
simple example that tries to explain the concept. Imran, continue. Somebody ring my door.
Okay. Step two. R
And
equals B.
Anirudh is also
Sorry.
asking him to add. Yeah.
Yeah, yeah. Last. Is the same thing somebody else was also trying to say to ask Anuruddh to join in?
Yes, yes.
Okay. Hi Anuruddh, are you ready to explain the algorithms to us? Well,
Yeah, I prepared prims and extras and little bit of
okay.
Bellman code, so I can explain
Okay.
two of the algorithms.
Great. So once we are done with the revision of these blue slides, then we'll go on to then you can go ahead and explain to us the algorithms that you prepared. Okay.
Sure.
Okay. Moving on. The difference between time complexity and space complexity. So time complexity calculates the time. Space complexity calculates the space of the memory. Um, then space time complexity depends on the number of statements. Yeah, it calculates all the statements, and space complete complexity calculates what? Counts the memory space for all variables, including inputs and outputs. And the time complexity mostly depends on the input size. Space complexity depends on the auxiliary variable size. Time complexity is more important for solution optimization. Space complexity is less important with modern hardwares. Time complexity of merge sort is O n log n, and space complexity of merge sort is O n. So may I give me 1 point on the difference?
Time complexity depends on the input data size, and space complexity depends on the auxiliary variable size.
Okay. Kritika?
Time complexity counts time for all statements, and space complexity counts
Space?
memory space for all
Variables,
inputs and outputs for all variables.
including input
Inputs
and
includes inputs and outputs.
okay, great. And then the other two statements were last one was the space complexity algorithm for merge sort is O n log n, and that's for the time complexity, and the space complexity algorithm for merge sort is O n. And there was one more point, right?
Solution optimization is for time complexity,
Yes,
and um, and
So with
auxiliary
modern
because of
hardware,
modern
and
hardware.
time
modern
complexity is more important.
Correct.
space complexity. Yes.
Yeah, more important with solution optimization, less important with modern hardwares. depend mostly on input size, depend mostly on auxiliary variable size, counts time for all statements, counts memory space for all variables. Okay, great. Write an algorithm to bubble sort in ascending order. So here we begin, we read an array and the length of the array. We loop from the second element to the last element. Then for I equals 1 to n, uh, loop from the last element to the current element. For j equals n to I, swap two adjacent elements if they're not in order. Array j is less than equals to array j minus 1. Swap j, array j and array j minus 1, and end. So my sister was saying that this should be n minus 1 according to the book. So please check this once.
Yes, maybe it should be n minus 1 because we are going to the last element.
Yeah,
Okay.
it should be n minus 1. We are zero based index, so from 0 to n. So 0
And will
to n
this
minus
be n
1.
minus 1 or will this just n?
This will again be n minus 1. And for I is equal to 0 actually. So I will
Well,
start with 0. The
No, I
first.
will start from 1, the second element, because we are comparing it to the element before it.
Uh,
okay, anyways, I'm not going to spend time right now, but just check and verify and update this, okay? Show all the steps in the application of bubble sort algorithm. So here in the iteration 1 where I equals 1, we start from the second last element and we swap in case if it's needed and keep swapping up until we reach the first element. Uh, 5, 4, 3, 2, 1, j equals 5, 4, 3, 2, 1. Will it be up to j equals 0 or will it be j equals 1 only? So there are 5
Up to 1,
because there
up
are
to
6
whatever
items.
I is.
Okay, fine. Cool. And then I just continue with this iteration. Okay, stack. Stack is a linear data structure which follows a principle called first in, first out. Um, it just has one end, which is the top, and the pointer is always pointing to the top of the stack. The elements can be inserted from the top and removed from the top itself. Stack has one end, whereas queue has two ends. It contains only one pointer pointing to the top element, topmost elements of the stack. Whenever element is added, it is added at the top of the stack, and elements can be deleted from the top stack, which is the same thing we discussed. In other words, a stack can be defined as a container in which insertion and deletion can be done from one end, known as the top of the stack. This is an example. Suppose we want to store the elements in the stack. Let's assume the stack is empty. We have taken stack of size 5 as shown below, which we are pushing the elements one by one until the stack becomes full. Since our stack is full, as the size of the stack is 5, in our cases, we can observe that it goes from the top to the bottom where we were entering the new elements in the stack. Stack gets filled up from the bottom to the top. Following are some common operations implemented on stack. Push. Okay, no, I'm not going to say that. Okay, so may I give me one operation on this?
Pop is used to remove the topmost element of the stack.
Okay, Kritika.
Push is is used to add one more,
Add an element at the top of the stack.
add an element at the top of the stack. Yes.
Okay. There's one that Somaya keeps talking about every day, and that's what?
Peak.
Peak. Which
She
is
always
like,
says peak.
yeah, always she tells that. I don't know what happened to her today. So peak is like getting an element from the top of the stack. Am I correct?
yes.
The first element.
First element. Okay. Okay. All right. Anirudh, give me one of the operations on stack.
Is full or is empty. So is full is to check if the stack is full, and the capacity is reached, and is empty is to know if the stack is empty, there are no elements in the stack.
Okay, and then there is change, which is used to change the element at a given position. Uh, what does change pair with, Kritika?
Display.
Display, yes, yes. That I keep
And
talking
peak
about every
also
time. I
pairs
forget.
with something. Peak also
Which
pairs.
one?
Uh,
Peak.
Tell me which. Yes, peak is the first one. So you say it.
Count.
Yes. So peak is the first one. Count is all of them.
Yeah, yeah. Peak is the first one, and count is all. Counts all the elements in the stack, right? And displays to display all the elements, right? So I think we
Yes.
covered everything. Excellent. Okay, write an algorithm to reverse a string. The logic here is that you take an empty stack and then you go ahead and insert all the elements inside of it and then remove them. So let's just quickly write the logic for that. Log.new. So it was reversing the string, right? Yeah. So read the string, count the, and store it in a variable, I think S, in S. Count the length of the string, which will be n equals count. Is it count function that counts the length, or is some other function? Somebody check.
Different in different languages, so it can be length or something.
Okay, no problem. So we got the length, and then we create an empty stack. Create an empty stack. So that will be S equals, no, not S. Stack equals, not S. Create stack, and then iterate through the string and push each character string to stack. So that will be push. First is stack, second is the element you want to push. That will be si, and there will be a loop before this. So that will be for I equals 0 to n. Will it be 0 or will it be 1?
0 to n minus 1.
Or it can be 1. No, no. 0 to n
No,
minus 1.
it will be 0 to n minus 1.
Yes. Okay. Then iterate and pop. Remove the elements, characters, and store it in string. So this will be S I equals pop, and that takes stack. We don't need to pass an index because I'll anyways pull it from the top, and then display the string, reversed string. Tell me if I made a mistake anywhere. If anybody has the it's
I think it's correct.
okay, let's verify. So begin read the string. Oh, this should be an
You
array.
didn't put the second for loop.
Yeah. Begin read the string, compute the length of the string. So yeah, it is length actually here. Length of S. Create stack, right? For I is equal to 0, I n minus 1. Now I'll not forget the n minus 1. I hope so. As I pop stack. Yeah, all good. All good. Moving on. Algorithm to insert an element into a singly linked list. So the logic here is that you allocate a new node. If the new node is null, you write overflow, go to step 6, and then the data part of the new node will be equal to value, and the next part will be equal to head, and then you set the head to the new node. And this is your diagram for that. And you exit. So inserting a new element in a single linked list at the beginning is quite simple. We just need to make few adjustment in the node links. There are following steps which need to be followed in order to insert a new node in the beginning of the list. Allocate the space for the new node and store the data into data part of the node. This will be done by following statement: struct node malloc size struct node ptr data item. Make the link part of the node pointing to the head to the existing first node of the list. This will be done by using ptr next head. At last, we need to make sure. So you'll only write one of these. You're not going to be writing everything. You want to explain, you can explain in these steps itself. Okay. And this is insertion at the end, and this is insertion in the middle. If you want to insert at the end, then all the steps are the same. You just change it from here. Set temp. So we need to create a temp in both cases, whether you want to insert it in the end or in the middle. So we create the temp. We set the temp equals head. We traverse to the last node, while temp next is not null, because if it is null, then that means we are at the last node. Set temp equals to temp next, and then set the new node equals date new node data equals value, and temp next equals new node, and then we exit. Then allocate new node. If new node equals null, what write overflow, go to step 7. Set temp equals head, traverse to node just before required position for I equals 1 to post. If temp next not null, set temp equals temp next. Set new node data equals val. New node next equals temp next. Temp next equals new node exit. Sumaya, can you do these guys quickly and share your screen and do it on the doc?
Okay.
Hey, there's one more person joined. Hi, Malvika.
Yeah. Hi everyone.
Is it the first time you're joining it?
Yeah. Today I joined.
Okay. So you are in the second semester, and you'll also be giving the exam on Friday and Saturday on PSA and Java, right?
Yes.
Okay. So tell us a little bit about yourself. Like, are you working or just a student?
Um, yeah, I'm working as a software engineer for in Bangalore actually.
Kritika,
I work into C language and yeah, internet
which company?
working. I'm working for HCL.
Nice. So everybody here has a reason why we are completing studies. Somebody wants to uh, go like travel abroad. Somebody wants to take an admission in higher studies. So what motivates you to complete these
Yeah,
studies?
my reason is the same actually. For the immigration purpose, I need to score some marks by getting the degree.
Okay, okay. To improve your score,
Yeah.
express entry.
Yes.
Okay,
Yes.
which country are you trying for?
Canada.
Okay, no problem. Cool. So Kritika is also in Bangalore.
Hi, Malvika.
Yeah. Hi, Kritika. So you're giving exam from Bangalore only?
Yes.
Okay.
Um,
Okay.
my center is BIT, Bangalore Institute of Technology. What's yours?
Mine is Pune actually.
Oh,
Anirudh is my brother-in-law actually. We joined this. We enrolled into this course together.
oh, okay,
Uh,
nice.
yeah, yeah. So
Okay.
I today only I came to Pune for exams.
That's good.
Okay.
And how many more people you're gonna get?
Hey, you tell me how many you want.
Just about enough. Okay, so you're writing the algorithm begin, then allocate new node. If new node equals null, write overflow. Uh, you can write exit or you can just go to the last step. It's fine.
Yeah. I set temp equals head. So this is for inserting at the end of the list. So traverse to the end of the list. While temp next is not null, temp equals temp next.
Can you also explain, maybe write it and then explain it?
Okay. So now we've gotten the last element of the linked list after this loop. Temp is the last element. So we have to insert the new node after it.
Sorry, I didn't get that, Sumaya. Can you explain once again?
We're traversing to the end of the list using temp.
Correct.
So while temp next is not null, we're going to the next element. So we end when temp is the last element.
Okay.
Um okay, then we're inserting the new node after temp. So temp next should point to new node. Oh, I have to set the data of the new node also. So new node will be inserted after temp, and uh, I think this is it, right?
I think last step is missing. So next of new node, we have to make it null. New node next equal to null, because now new node is the last node. So next of new node should be null now.
Yeah. Okay, should I write for inserting the middle also?
Yeah, just 1 second. Anirudh, can you explain what's going on here?
Yeah. So we are beginning, then we are allocating memory to the new node by using malloc. Uh,
Mm-hmm.
then in third step, if new node is equal to null, then we write overflow. If the memory is not allocated, that means somehow memory is full. So we just write overflow and exit. Then in the fourth step, we are creating a temporary variable which is equal to head in the beginning. So we want to iterate through to the end of the linked list. So we are creating this temporary variable to iterate through the list. And then in the fifth step, we are traversing or iterating to the end of the linked list. So while next of temp is not null, we are moving temp pointer to next of temp. So we are increasing temp one by one in each step of this while loop until it reaches to the end of the linked list. So when temp of next of temp is null, then it means that we are at the end of the linked list, and then this while loop will break and will come to step 6. So at step 6, now we are just assigning the data to this new node that we have created. This value will be given in the input and we'll assign this data to the new node. And in the sixth step, then we come to seventh step, in which right now temp is our last node. So we want to make the new node as last node. So next of temp will point to the new node. So that new node becomes the last node, and temp doesn't remain the last node. Temp becomes the second last node now. So for that, we have written the seventh statement.
Yeah.
So next of temp will point to the new node now. and next of new node will point to null, so that new node is the last node of the linked list, and next of new node should point to null.
Okay, excellent. Thanks, Anirudh. Sumya, please go ahead and do the next one.
Okay. So the first four steps are the same. Uh, then we have to traverse to the required position instead of the last one. Traverse to one node before the required position. For I equals 0 to, I think it should be position minus 1. Then if the next pointer of temp is not null, then set temp to the next to the next node. And then we set new node's value and new node next. So the next pointer of new node will point to the next pointer, will point to the what temp is pointing to next.
Okay.
And then we set temp next is new node. And then exit.
Okay, Anirudh, can you explain this part?
Yeah. So it is similar to inserting at the end only, but now we have to insert at certain position. So we
Mm.
want to traverse till that position. So that is the
Correct.
only difference. So we
Mm.
are starting at 10th step, then we are allocating memory to the new node at 11th step, and at 12th step we again check the same condition. If new node is equal to
Yeah,
null,
let's
we
skip all of those. Let's move to the
yeah
14th one where it's
yeah.
changing.
At the 14th one, basically we want to traverse to the position
Which
where
is
we
given
want
to
to
us.
insert. So travel to
Yeah,
the one node before that position, uh,
we want to insert that.
because we want to insert there, so we need the previous node. So we will point the next of the previous node to the new node. So that's why we need the previous node,
Right.
because we want to change the next pointer of the previous node. So that's
Correct.
why we are traversing one step before. So that's why it's from 0 to position minus 1.
Yeah.
And then we also check temp of next is not null, then only we move the temp is equal to temp dot next.
Mhm.
If it is null, then it means that we have reached the end of the linked list. So that's why this is a validation check basically.
Yeah.
So from this 14th step, we are at a position just before the position that we require to insert this new node in.
Yeah.
Now, basically, temp is the previous node, and next of temp should become new node. So that's what we want to do right now. So what we are doing is in the fifth step here, we are allocating data to new node, and then We are pointing next of new node to the next of
Temp of
temp.
next.
So
Yeah, because it
between
holds the
temp
previous
and temp of
side.
next, we have to insert new node basically.
Yeah.
So there are two nodes, one is temp next, and between these two, we have to insert new node.
Hmm.
Okay. So new node, the next of new node should point to next of temp, and temp of next now should point to new node. So that's what the sixth and seventh statement means basically. So we want to break the link from temp to temp dot next, and we want to insert new node between these two nodes.
Now, I'm a little confused at point 14 where temp is capital T. Why is it capital
It
T? It should
should
be
be small.
small.
I think it's a typo. I think.
Hmm.
So now we yeah. Shall I repeat it? Uh,
Yeah, just from
After the
that
14th
temp
statement.
equals temp next. I get the point 5. Uh, I get the point 6 also, but I'm just trying to understand why temp equals temp next there. What's happening there?
Which step?
In step 14, there's temp equals temp next.
So this is basically iteration. We are just moving. So in the beginning, temp is pointing to head, and we want to
Okay.
move like 5 positions. So we are moving
Mm.
one by one. This is inside the for loop. This is happening inside the
Oh.
for loop. So we are moving one by one.
So basically,
Hello. Shall I explain via an example or hello? Uh, Imran, can you hear me?
You are audible,
We can hear.
Amrit. Mm.
It's easy to understand this through diagrams.
Yeah, I think I can share my screen. I found one good example here. Let's maybe wait for Imran to join back.
hello.
Yeah, Imran.
Yeah, sorry. I think electricity went off and came back, so I lost everything. So yeah, I think it's clear. We can move on.
Shall I explain with one example? I think it would be more clear
Yeah,
if
that'll be great if
you can
you
share
maybe
the
share your
screen.
screen and explain.
Yeah. Is the screen visible?
Yeah.
So basically, if we consider this diagram, so this is the temp node, and this old link is the next of temp. And now what
Hmm.
we want to do is we want to insert a new node between these two nodes. Okay. So what we are doing in the first step is we are pointing the next pointer of new node to temp next. So this is the temp next node basically, this one. And then we have created this link, this particular link by that statement. Okay.
Hmm.
And then in the next statement, what we are doing is creating this link. We are pointing next of temp to new node. Now, if by this statement this link is created and this
Hmm.
link is broken,
Hmm.
so now after executing those two statements, our new node is inserted between these two nodes, between temp and next of temp.
Okay. Sounds good.
Okay.
Perfect. So moving on. Let me try to connect to my Wi-Fi, see if it's working now. Yeah, am I audible?
Yes.
Mm.
Hello?
Yeah, Imran, you're audible.
Okay. You guys can hear me, right?
Yeah.
Yes.
Okay, good. I just switched to my Wi-Fi. Okay, let's move on. So Malavika, so does anybody in your friend circle like has an experience with the IGNOU? Like, do they provide transcripts, and has anyone successfully used this degree to get their PR or get admission in Canada?
Mm,
Do you know?
mm, Not really, but one of my friend referred me to IGNOU because it's included in WES. So degree of IGNOU will be verified with WES. It can be verified with WES, and it is considered as a diploma and adds around 32 points in express entry.
Hmm. Okay. So, like once we are done with the exam, then we have to approach IGNOU to send the verification details to us, right?
Yeah, yeah. So we have to create an account on WES website, and then we have to send that reference code to IGNOU. So IGNOU
Yeah.
should send the transcript to WES directly.
Okay, and I'm 200% sure these guys will take around 2 3 months to do that because because everything is so slow here.
Yeah,
June.
could be in my for my BTech normal degree. It happened like in 1 month, but yeah, depends on the
Happened
university.
one month. Okay,
It was
that's not bad.
completed in 1 month, and it reached to the WES and got verified.
Oh, that's not bad then. 1 month is fine. I completed my graduation from Mumbai University, and that verification was done just in 4 days. You know, everything online. Just in 4 days, verification was done, and I got the certificate also. That's how quick they are. But yeah,
It's really
but still
fast.
1 month is also fine.
Yeah,
Cool.
Are you
it's
So
also
it's
doing this for express entry, Imran, or?
I'm already in the pool, but my
Mhm.
points are not that much. Uh, so I'm in pool for last 6 months. My
Okay,
point is
okay,
what 346 is my points currently.
okay, okay.
So I thought that maybe going through an education route might be good
Yeah.
because I completed my studies almost 2 to 3 years ago, not 2 to 3, but almost 10 years ago. Uh, there's a gap, and plus the graduation was done in arts, and now since last 4 years I'm into tech field,
Mhm.
so that's kind of not matching with my education, and plus my scores were less because I didn't really study. I didn't even buy the books, and everybody was saying just complete your graduation. So just for the heck of it, I completed that. So probably I might be able to convince them, saying that I have good score and I've recently done my studies, so it's not like I've done it. There's a huge gap, and this can help me in my career, in my work uh, as well, because it's the same field. So I feel that might convince them to get the student visa.
Yeah, I think so too. And I think some of the courses like algorithm is really useful in job interviews as well.
Yes, I mean job is the last thing I have to worry about because I'm already working for last 4 years in a good company. So, but yeah, mainly for student visa, yes, that will be good.
Mhm.
So let's hope for the best. So coming back to tree, so tree is a non-linear data structure, and it's used for hierarchical data. For example, if you want to represent the employee and their hierarchy in a company like this, each of the tree has the main node called root node, and then you have child nodes, uh, and the ones which are adjacent to each other are called siblings. The ones that don't have the children are called leaf nodes, Parent are also called ancestors. Children are also called descendants. And then each of the nodes can have any data type, and it should have some can have some data. Okay, so one of the data structure represent hierarchical data. Tree structure defined as collection of objects known as nodes linked together represent a similar hierarchy. Non-linear data structure, because it does not require sequential manner, it is a hierarchical structure as elements are arranged in multiple levels. A topmost node is root node, contains some data. Data can be of any type. Yeah, each node contains some data, link or reference to the other nodes. Yep. Moving on, how a tree is different from the binary tree. So one of the point is that the number of nodes in a general tree can be more than two, uh, but can be multiple. But in binary tree, it's maximum two. Kritika, give me another point on this if you recall for the difference between general and binary tree.
A general tree can be empty, but a binary tree cannot be empty.
Okay,
It's the other way around.
binary tree can be empty, I think, right?
Yeah, yeah. Binary tree can be empty, but general tree cannot be empty.
Oh, okay. Okay.
Kritika, now you'll not forget.
Yes, I thought it's according to the picture here. And because the general tree seems empty and binary seems, so that's why I got. Okay.
Hmm. Okay, picture is confusing. Okay, so may I give me another point if you remember?
Uh, a tree can have the ordered property, and a general
Hmm.
tree does not have ordered property.
Okay, so binary tree can have ordered property, general tree don't, not necessarily. Okay, all right. Anirudh, do you remember any differences?
No, not really.
No worries.
And
Oh, somebody put a nice tree there. Who did that?
I did that to remember
Nice.
that this can be empty. And I still
Oh,
got confused, so not nice.
I think the other picture confused you. You kind of, yeah. So maybe put that picture there because we may not always come to this right. Always remember, like it's on the right hand side, the binary one.
Yes.
Yes.
Okay. So general tree is a tree in which each node can have many child nodes, while binary tree, each node can have two nodes. Uh, General tree cannot be empty. Binary tree can be empty. The subtree of general tree do not hold ordered property, while the subtree of binary tree hold the ordered property. So Sumaya, it's a subtree. You have to specify subtree here. Okay. Um, in general tree, there's no limitation on the degree of the node. Yeah, I think we spoke about this. These guys go hand in hand. That because you can have more than two nodes, that's why there's no degree. There's no limitation on the degree of the node. But here, because you can have maximum two nodes, there's a limitation on the degree because the nodes in the binary can't have more than two child nodes. In general tree, there's either zero subtree or many subtree, while in binary tree there are mainly two subtrees, left tree and right subtree. Okay, so just a recap, general tree can have more than two nodes, so multiple child nodes. Binary tree can have maximum two child nodes. The point linked to that is because of this thing, general tree um, does not have a uh, degree of what? Degree of
not have a
nodes?
limitation on degree.
Yeah, no limit on the degree, correct. And the binary tree have a limit on the degree because they can have maximum two child nodes. General tree have, yeah, binary tree have left subtree and right subtree, and general tree can have a number of subtrees. Again, there is, I don't think there's a limit there. And binary tree, as per the picture, can be empty, while general tree cannot be empty. And the subtree of the general tree have can yeah may or may not be ordered. However, the binary tree subtrees are ordered. Okay, so I want now somebody else to recap this as many points as they can. Who wants to take? So may I want to try?
Okay.
Yeah,
So a binary tree can have any number of children. Uh,
yeah.
a node a node in a general tree can have any number of children, and a binary
Hmm.
tree can have at most two child nodes.
Yep, yep.
Um, the subtrees of a general tree do not have ordered property, and the subtrees of a binary tree can have ordered property.
Yep.
The general tree cannot be empty, and the binary tree can be empty.
Okay.
In the general tree, there is no limitation on the degree of a node, and in binary tree, there is a limitation on the degree of a node because it can be two, at most two.
Child
Um,
nodes. Okay. What was the last point about
a
subtrees?
general tree can have it has two types of subtrees: a zero subtree and a many subtree. And a binary tree has left subtree and right subtree.
Okay. Anirudh, you want to try? Give some of the points.
Yeah, so general tree can have any number of any node can have any number of children, and in binary tree any node can have at max two child nodes.
Yeah.
And linking to this point is general tree do not have a limitation on the degree of a node,
Hmm.
and binary tree have a limitation of two or on a degree of node. So at max there can be two subtrees, so the degree is two at max. And tells the subtree of general tree do not have ordered property, while subtree of binary tree has ordered property.
Hmm.
And binary every node in a general tree can have zero or many subtrees. In binary tree, every node has left subtree and right subtree. I think
Okay.
and binary tree can be empty and general tree cannot be empty.
Perfect. Perfect. Excellent. Perfect. Okay. So two types of traversals. Actually, there are three. Um, but here in the paper they're asking two. So it's pre-order, post-order, and then if you want the third one, there's the in-order traversal. Pre-order traversal of the binary tree means you go pre-order, post-order. Is it top to bottom or bottom to top? Can somebody remind me?
Top to bottom. The
Top
parent first, the child later. The parents
pre-order.
come first. Yes.
I'll link pre with the parent. Parent should be pre, like first parent. Okay. So we start from the root node, then we go here, 12, then we go 5, then we go 6, then we go 9. Okay, so that's your pre-order. Then in post-order, you get from child to parent. So you go 5, then you go 12, you go 6, you go 9, and then at the last you do the node.
5 and
Root
6 first. All the children
all the
will come
children first.
first.
Okay, good. So all the children first, so 5, 6, then 12, then 9. If there were children here, you would have first gone on the children before going on 9, but in this case, we'll go on 9, and then root will be at the last. So in pre order, root will be the first thing you will traverse to, and in post order, root will be the last thing you will traverse to. So pre order is from parent to child, and post order is from child to parent. And then for the in order, you go and start from the left subtree and then go up until the right subtree in the reverse order, which means child to parent. So I think you'll go something like 5 6, no, 5 12 6 or 5 6 12. So yeah,
5, 5, 12, 6.
5 12 6, and then you do the go to the root and then you jump to the right subtree, whatever the nodes were there. So let's see if that's true. Each node is visited before the children are visited. Root is visited first. Visit root node, traverse the left subtree in pre-order, traverse the right subtree in pre-order. 112,569. Excellent. Time complexity of pre-order traversal is Tn equals On, where n is the number of nodes in the tree. Two types of traversal of binary tree: post-order traversal. Uh, Here, the children of the node are visited before the node itself. The root is visited last. Every node is visited after its descendants are visited. Algorithm: traverse the left subtree in the post order, traverse the right subtree, and then visit the root of the root node. So 5, 6, 12, then 9, then the root node. So root is at the last. Same thing, time complexity of post order is also T N O N, where n is the number of nodes in the tree. Third type of traversal is your in order, which says that go traverse to the left subtree, then go to the node, and then traverse to the right subtree. So in order will be 5, 12, 6, then 1, and then 9. Okay. Binary search with example. Binary search is an algorithm used in sorted array by repeatedly dividing the search interval into half. The idea of the binary tree is to use information that array is sorted and reduce the time complexity to O log n. Algorithm: the basic steps to perform the algorithm are: begin with the middle element of the whole array as a search key. If the value of the search key is equal to the item, then return the index of the search key. If not, then if the value of the search key is less than the middle element of the interval, decrease the interval to the left half. Did you update this, Anirudh?
I updated the example and I verified the Kritika's update, I think.
Okay. So if the value search key is less than the middle element of the interval, then decrease the interval to the left half. Otherwise, decrease to the right half. Okay, good. Repeatedly check for the second point until the value is found or interval is empty. Okay, nice. Start from the mid element. Oops. Consider an
Uh,
array 3, 4. Sorry.
shall I explain this? I added this.
Yeah, go ahead.
Yeah. So basically, let's consider an array 3, 4, 5, 6, 7, 8, 9, and we have to search an element 4 in this array using binary search. So we
Mm-hmm.
start with the mid element. In the beginning, we mid element is 6, that is
Mm-hmm.
in the middle of the array. And we
Mm-hmm.
compare 6 with 4,
Mm-hmm.
and now we know that since 6 is greater than 4, so we should move to the left half. So now 4
Yeah,
can be only found in the left half. So can you
yeah,
move to the next page?
yeah.
So now this is our left subarray. So we
Mm-hmm.
move to this subarray and then we again consider the middle element of this subarray, the left
Mm-hmm.
subarray, and then we again compare this middle element to the search key that we want to find. So now
Mm-hmm.
4 equals to 4. So that's when
Match is found is returned.
we can return the index of this element, which is
Excellent.
1.
Cool. So you first because it's already in sorted order, you get the middle element, you compare that with the element that you're trying to search. If the match is found, you return it. If the match is not found, you check if that element that you're trying to search is greater or smaller. If the element is smaller, then you check on the left hand side and again divide the left part of the list by 2, get the middle element, which is what's happening here. And if the match is found, return it. If not, again repeat the steps that we just spoke about. Correct?
Yes.
Okay.
I think in the last step I missed that n by 2 thing.
Yeah, these
Yeah.
guys.
More elements continue to divide. Yeah, you mentioned it. Yeah.
I think even if you write it in your own words, as long as you're explaining if the match is not found, it's fine.
Yeah.
Just like even if you just add one more line that in case if the match is not found, just repeat steps from so and so up until so and so. And just a repetition, nothing else. Okay, algorithm for addition of two matrices. So I think we established yesterday that the two matrices need to be equal in number of rows, number of columns need to be equal for it to work. And we declare and initialize two-dimensional arrays A and B. Calculate the number of rows and columns present in the array A and store it in the variables rows and columns respectively. Declare another array sum with the similar dimensions. Loop through the arrays A and B and add the corresponding elements. Display the elements of the array sum. Okay, so who can explain this?
Yeah, I can explain it. So,
Okay.
so yeah, the precondition here is the number of rows of the both the input matrix, number of rows and number of columns should be same. Let's say
Mhm.
my first matrix has 3 rows and 3 columns, so second matrix should also have 3 rows and 3 columns.
Yeah.
Then we start the algorithm. Then only we can perform addition. So we
Mhm.
declare and initialize two-dimensional arrays or matrix A and B.
Mhm.
First one is A, second one is B, and calculate the number of rows and columns present in A and B, and store it in variables named like rows and columns.
Yeah.
So calculate the rows and columns in A and B.
Mhm.
Declare another array. This here instead of array, you can write matrix or declare another 2D array, some with
Okay.
similar dimensions,
Mhm.
and loop through the arrays A and B. So there will
Mhm.
be two loops inside one another. We can write a kind of a pseudocode here also, like at other places we wrote for I is equal to 0 to rows minus 1, for j equal to 0 to column minus 1,
Mhm.
a sum of ij equal to a of ij plus b of ij.
Okay. Anirudh, like tomorrow, can you write proper one algorithm over here and paste it here?
I
Just
can
the
do that.
algorithm.
Only the fourth step needs to be changed. Rest is fine. I will do that.
Okay, no problem. I'll assign it to you.
So basically, we are iterating through every element of both the arrays, and we are just adding them and storing them in the new matrix.
Yep. Okay. We are close to done, so let's keep going. We have less number of questions. That's also scary. That means we haven't prepared enough content. Okay, depth first search with example. So let's try to recall what depth first search was. Does anyone remember what it was?
You put the unvisited nodes in a stack. You
Yep.
can start from any node and then put
Hmm.
its edges and nodes in the stack, and then visit the next node from the stack.
Correct. So let's say there is a graph which contains vertices and nodes, and let's say you're starting from zero. What you need to do is you need to first whatever node so there are two what do you call those stack and visited nodes. So you create those two lists basically. One for the putting the stack, one for maintaining the stack, and second for visited nodes. So if you visit the first element, let's say zero, you put that in the visited one, and whatever the adjacent nodes are there, you need to put that inside of the stack. Then in the next step, you will visit the first item in the stack, and then you will remove it from the stack and place it in the visited one, and again look for what are the adjacent elements available, and then follow just the same process. So DFS implementation puts each vertex of the graph into two categories, visited and non-visited. The purpose of this algorithm is to mark each vertex as visited while avoiding cycles. Works as follows. Start by putting any of the graph's vertices at the top of the stack. Make the top item of the stack and add it to the visit. Take the top item of the stack and add it to the visited list. Create a list of vertex adjacent nodes. Add the ones which are not visited to the list at the top of the stack. Keep repeating 2 and 3 steps until stack is empty. So you can explain this part in your own words, but I think at least couple of sentences that we can write is it puts each vertex of the graph into two categories. We can write that, and then the purpose to mark each vertex as visited while avoiding cycles. Okay, mark each vertex as visited while avoiding cycles. That's the purpose. And now we'll go and take a look at the example. Okay, so we basically visit the first one, put that in the visited, put these guys adjacent ones 1, 2, and 3 into the stack, then visit the next one, which is 1, move it to the visited, put the adjacent ones in the stack, but because the adjacent ones are already in stack, we don't need to touch anything. And then next element is 2, so we visit that, put that in the visited, and put the adjacent elements in the stack. So adjacent element was only 4, so we put that. Then visit 4, move the 4 to the visited one, and then put the adjacent element in the stack, but there are no adjacent element here, so we'll leave that. And then finally we visit the remaining one in the stack and put that in the visited. So since all the vertices are visited, that was the goal of this particular algorithm, which is depth first search, and it does not form a cycle, so that purpose is achieved. Moving on. Circular queue, how does it differ from a queue? So I think in circular queue, uh, the first and the last elements are joined together to form a circle-like structure. And if you have a linear queue, the problem with the linear queue is that in case of the queue is full and you want to insert an element, even at elements I think are generally inserted at the rear. Even if there's a space at the beginning, you can't really do anything. So to solve this problem, circular queue is used because the first and the last elements are joined together to form a circle-like structure. So you get to add the element in the circular queue. Okay, Kritika, can you read this?
A circular queue is the extended version of a linear queue where the last element is connected to the first element, thus forming a circle-like structure.
0.75.
A circular queue.
No, you
Okay,
can go
I'll
to the
go to
next
the
one now
next one.
with that speed.
Initially, the front or the head and the rear or the tail pointers will be pointing to the same location in the circular queue. This would mean that the queue is empty.
Okay.
Addition, new data is always added at the rear pointer. Once the data is added, rear pointed is incremented to a point to the next available location.
Okay.
Deletion, the head pointer is incremented by one position when DQ is executed.
Okay.
The head and the rear pointer will get reinitialized to 0 every time they reach the end of the queue.
Mm-hmm.
In a normal queue, we can insert elements until queue becomes full. But once the queue becomes full, we cannot insert the next element even if there is a space in front of the queue. In a circular queue solves this problem by utilizing space more efficiently than a regular queue.
Okay. Uh, Anirudh, do you know circular queue? Would you be able to explain?
Yeah, you can explain
Maybe
an
if you can
example maybe
explain.
in this
Yeah,
diagram.
so we have an example. Where is it? Did we not have an example? We did. I have to go to
And
the.
from these photographs only I can explain, I think.
No, basically, what I want you to explain is how the insertion and deletion works in circular queue. That's what I'm interested in. Uh, that's a bit confusing, actually. We did have a. Where did we copy this? We copied this from somewhere, right? We didn't put the link there.
I think I can explain why this only, otherwise.
Yeah, the thing is, how insertion and deletion work, how these guys start moving.
Okay, okay.
1 second.
Let me just
Insertion,
find the link also.
deletion in circular queue. Just 1 second. Maybe this.
Yeah, I can explain why this.
So I'll stop my share. Maybe you can share and explain.
Can you share this link also? I didn't get the link.
Yeah, I'll do that.
Okay. So is the screen visible?
1 second. Yeah, now it is.
Okay. So basically, let's consider an empty queue,
Mm-hmm.
and this is a circular queue. This doesn't feel like a circle, but I will explain how it is a circular queue. Basically, you
Okay.
can imagine uh,
Just opening it
queue to
into
be like
a
this.
straight. Yeah, I'm
Yeah,
just kind of breaking it from
yeah,
that
yeah.
zero.
Yeah, so this queue is structured like this: 0, 1, 2, 3, 4, and then 0 and 4 are also connected.
So from that point, I kind of cut it and then straighten it.
It is in that structure only, but to be
Like,
for simplicity, it is shown like this. But it is
yeah.
in actually in that structure only,
Okay.
and we'll explain how it's implemented. So
Mm-hmm.
we are pointing front as -1 and rear as -1 in the beginning. Both are pointing to, let's say, this node which is present as 0 right now, or
But how is it
this is
minus
not
one?
even, this is -1 actually. This is not even 0. So they are pointing to some random pointer, I would say, or random pointer which does not exist in this array. Okay,
Mm-hmm.
in the beginning.
Mm.
Now when we add 10, then we add 10 to the next of rear. We increment the rear to -1 to, we increment it by 1, it becomes 0, and at this index we add an element 10. Okay,
Mm.
so now the rear becomes 0,
Mm.
and the front also,
Front
we
also
consider
becomes
this.
zero. Yes.
This is a bit confusing. I will come to this
That's what
later.
I'm saying. It's just confusing. Yesterday we tried it.
I think only this step is a bit confusing, the -1 to 0, but all the other steps are fine. Let me just come back to that. Let's say this is added at first element is added, both become 0.
Mm.
And let's say we add one more element 20, then rear becomes 1. We add one more element 30, rear becomes 2.
Mm.
Okay, so we are adding at the rear end. Now we
Yeah.
added 40, rear becomes 3, front is still 0. Now it becomes full. We have added 50 and rear becomes 4. It becomes full. Now we have to delete an element, and element will be deleted from the front, always from the front. Okay, so the front element is deleted if we delete one time, and the front pointer will point to this one.
We have deleted
If we
two
delete
elements.
only one, if we delete one element, it will point to 1. If we delete two elements, then it will point to 2.
Mm.
Okay,
Mm.
now these two spaces became available. Now these two spaces are available. These two are empty elements in the array or in the queue. We can add some values here. Now if you want to insert something, we have to insert at next of rear. Now since we know that next of rear is 0, next of
Yeah.
last is 0, because this is a circular queue. Okay,
Hmm.
so we insert at the next of rear and rear becomes 0. After 4,
Yeah.
rear becomes 0,
Hmm.
and it element is inserted here. Now the
Yep.
front is 2 and rear is 0. Similarly, if we insert one more element, rear becomes 1, and we have added 70, and front remains the same.
Awesome.
If
I
we
think
delete some element, now if delete some element, front will point to 3, and this space will become empty.
yeah, understood.
Only the
So
first point is confusing. I think, yeah,
it's
we need
everywhere.
to
I
do
saw
some
another
research.
example, it's the same thing.
I think we
You
can
saw
start from the second step also, like front will can point to 0. Yeah, not 100% sure, so shouldn't comment on this.
yeah, no problem. So if you stop share,
Yeah.
thanks. See this -1, both have pointing. So the only point is that the very first time when this is empty, if you insert something, both will point to 0, front and rear. That's what's happening. Initially, the front
Mm.
and the rear will be pointing to the same location. In the circular queue, this would mean that stack queue is empty, which is this guy. Okay, new data is always added at the rear, like you said, and once the data is added, rear pointer is incremented to the point to the next available location. Which means if you add something, first time it will be at 0, but second time if you add, so first time will be 0. So when you add something here, element will be get inserted here. Just show me. Okay, wait a second, 1 second. So first time when the element is added on 0, they are at, okay, and the next time, but looks like it's pointing to wherever you inserted, isn't it? Rear is pointing to wherever you inserted the element, while here in this it's saying that uh, once the data is added, rear is incremented to point to the next available location. So that is a bit confusing.
I think both are not the same, but both are correct. Uh, so we can do it either way. We can do it as shown in the example. Also, we can increment the rear and then add to that location, or we can add to the rear and then increment the rear. I think the one in the slide is correct. In the example, it's a bit incorrect, I think.
Okay, where did we go? Yes, this is the one. Yeah, yeah, this is the one. So take a look at this. This is empty. First time any elements come, they both will point to the same location. Next time you are inserting something, then see the rear is pointing to wherever the element got inserted. It's not actually pointing to the next available location. That's so yeah.
I think we can modify the slide a little bit.
Hmm.
I think main point is just the insertion will be at rear and deletion will be from front, and both end of the linked list, end of this circular queue is connected to the first element.
Yeah.
So those
Let's
are the
add
reasons.
this screenshot for future reference. You should actually paste this link. Oops. There's one more. Okay. No worries.
In the book, it says in a circular queue, the front will point to one position less than the front.
When you add the data, what happens? First, let's go with that.
When you add the data, the rear is
Where will the
incremented.
rear point?
The rear will point to the data, I think, but the front will point to one position before the first one position before the first element.
When will it point to one position before?
Always, unless the queue is empty. If it's empty, then front and rear are pointing to the same location.
But that's not happening in the screenshot. That's what's confusing.
Yes, it's different in that.
Okay. I'll let you guys see. Maybe Sumaya, if you or Anirudh, you can take some time today and see what's the correct way, because we don't want to write something incorrect in the exam. See what's the right thing. Maybe whatever source is the best. If it's the book, then let's do it with the book. But let's write it properly. This is so confusing. Somewhere is saying something else. Somewhere is saying something else.
I sent a link. That's where I got some of the content on this slide from. But that is also a little different from the book.
Okay, we'll add this link here and we'll come back to this. It's taking too much time. More content. Add that link here. Okay, moving on. The difference between circular queue and a normal queue. So, linear queue organizes the data elements and instructions in sequential order, one after the other. Circular queue arranges the data in circular pattern where the last element is connected to the first element. Linear queue tasks are executed in order they were placed before, which is first in, first out. In the circular queue, order of executing a task may change. In linear queue, the new element is added from the rear end and removed from the front. In circular queue, insertion and deletion can be done at any position. Linear queue inefficient, circular queue works better than the linear queue. Okay. Uh, Kritika, let's read this.
Okay. Linear queue organizes the data elements and instructions in a sequential order, one after the other, while
Okay.
the circular queue arranges the data in a circular pattern where the last element is connected to the first element.
Mm-hmm.
For the order of task of execution, linear queue follows first in, first out, and in a circular queue, the order of executing a task may change.
Hmm.
For a linear queue, the new element is added at the rear end and removed from the front, while for a circular queue, insertion and deletion can be done at any position.
So tell me, see how this is contradicting. Now, there it is saying that elements are inserted from the rear end and deleted from the front, but here it's saying they can be done from any position. That's confusing.
Yeah, I don't understand the second and the third points.
Hmm.
Yes,
Okay.
even for the second, even circular follows first in, first out, what we were discussing.
Yeah. Let's see if we have any other differences, like any other place of difference, which is more in line with what we need between linear queue, circular queue. Insertion and deletion are fixed, done at the rear and front. Insertion is not fixed. See, this guy also looks like he's just copied or what. Let's see here. Yeah, let's see. Insertion is done from the rear, deletion of the end. Insertion can see how many people.
Maybe we have the concept of circular queue wrong. Do you think
Yeah,
so?
possibly. It's the last one I'm looking at. Do they have a difference here? Insertion, deletion. Okay, at least they have diagram. Let's see. Insertion is done from the rear, whereas deletion is done from the front end, hence they are fixed. Due to circular structure, we cannot distinguish the exact position of the insertion, hence they are not fixed. Due to the circular structure, we cannot distinguish the exact position of the insertion and deletion, hence it is not fixed.
I think what they mean is that the front and the rear can move around the circle.
Hmm.
So, so you can insert at any point.
Yeah.
Like the rear can go back to zero,
Hmm.
but in linear queue it is sequential.
Correct. So rear can shift, even come to the zeroth position, but here rear cannot shift and come to the zeroth position as we established. Like for example, now it is full according to the regular queue, which is the linear queue. The queue is full. If you want to insert item, even though these are spaces are available, you can't do that because rear can't shift. That's saying insertion not possible. But here the rear can shift. We established that, when, for example, let's say this was circular queue, rear is going to move over here and we can insert the item. So I think that's why they're saying that. So it's not wrong.
Yeah, sounds correct.
In linear queue, we can fetch out peak value. Circular, we cannot fetch out peak value because more space, less space. Give this inefficient utilization. Yeah, so I think we don't need to change anything here, right? And it's fine.
Yeah, it looks fine actually.
It's fine. But probably we can paste this link there so that if we get confused sometimes we can always come back and refer to that. Okay, fine. Let's try to recap this. So linear queue organizes the data in the linear structure. Circular queue organizes the data in the circular structure where the first element is joined to the last element, forming a circular like structure. uh, which is more efficient? Is it linear or the circular? Circular is more efficient, right?
Yes.
Okay. And another point that we discussed was the insertion happens at the rear, and the deletion happen at the front, which is first in first out in the linear queue. And the circular queue, because the rear position is not fixed, insertion and deletion can happen at any index. And then there was one more point, I guess. What was the other point besides these three? Tasks are executed in order they were placed before. Order of execution may change. So almost similar. I'm wondering, should we put this guy over here instead? This looks better, right?
Yeah, this one is better.
Yeah. Let's do that. Not even needed this diagram. Now that we already have one diagram there. Okay, let's move to the next slide. Compare two sorting algorithm, quick sort and merge sort. So I remember the point that in quick sort, the uh, sorting algorithm is O(n) square, and here is O(n) log n. Quick sort, the splitting of an array of elements is in any ratio, not necessarily divided into half. However, in the merge sort, the array is parted into just two halves, which is n by 2. Kritika, probably we should take one more session tomorrow where we discuss all the sorting. I remember you've done the binary search, so you might be able to explain. Can you take a session, let's say for half an hour or 45 minutes tomorrow, on explaining all the sorting algorithms?
Yes, okay, I can do that.
Uh,
So we have
See,
quick sort, bubble sort, merge sort, binary search, and we have more.
yeah, I'll
Heat
show you.
sort.
I think in that slide itself, there should be one slide which will give you a list of all of them, which is as per syllabus. So, but you can find it in syllabus also. So where is it? Uh, yeah, here it is. But there will be a slide there which
Heat
will
sort,
say
okay.
that it is sorting in the list. So insertion, bubble, quick, merge,
Mm-hmm.
and keep. Maybe skip the bubble, skip the one that we already done.
Okay.
Okay. Why is it not showing merge sort? Oh, here it is. Two-way merge sort. Okay, so insertion, quick, merge, and heap. Okay.
Yes, okay.
Keep it as precise as possible, just enough so that we can understand. So just
L-
some information and with some example.
Cool, cool, okay.
Thanks. So yeah, splitting of an array of elements is in any ratio, not necessarily divided into half. In merge sort, the array is parted into just two halves, which is n by 2. O(n) square algorithm of the worst case complexity, time complexity is O(n) log n. By the way, this is time complexity, not space. This works well on smaller array. It operates fine on any size of the array. Speed of execution, it works faster. Quick sort works faster on the sorting algorithm for small data sets like selection sort. Merge sort has consistent speed on any side of the data. Quick sort, additional storage space requirement is less. For merge sort, additional storage space requirement is more. The efficiency of quick sort is not good for larger arrays. Merge sort are more efficient for large. Merge sort are more efficient. Quick sort is an internal sorting method. Merge sort is an external sorting method. Quick sort is not stable. Merge sort is stable. Quick sort is preferred for arrays. Merge sort is preferred for linked list. Locality of reference is good. Merge sort is poor. I don't know how I'm gonna remember so many points. But yeah, let's try.
I think if we know the algorithm, then only it
Yes, I
would be
was gonna say
easier
that.
to.
Correct. Correct. And tomorrow is what, Thursday, right? So
Yes.
Yes.
and day after tomorrow is exam. So that
Mm.
means tomorrow for both sessions we'll just be doing DSA. We won't be doing uh, Java tomorrow. Okay. So we'll spend good enough time tomorrow on all of these. So first aim will be to complete all of these blue slides like we are doing today. Once you've completed them, then we're going to go and do the sessions on sorting algorithms, and then we're also going to go through the slides which we haven't covered in the like non-blue slides which have some content, so that at least we're aware about the other topics just in case if it comes in the examination. Whoever is comfortable with any part of the of this non-blue slides, go ahead and take that tomorrow. Feel free to do that. If you do it, it's going to be better for yourself only, because if you're going to explain things, then you will get better at it. Like Sumaya can't forget normalization, I'm sure, even till today. If any other student comes tomorrow and asks for it, I'm just going to forward them to you, Sumaya, in the
I did
future.
sorting, so maybe I can do maybe two of them, and Kritika can do two.
Yeah, let's do that. Let's do that.
Yes, yes, okay.
Cool. And feel free to pick up any other topic also from this, which you feel is important. Because yeah, just look at the syllabus. If you guys don't have, like, some of you don't have the link to the syllabus, I'll share that here in the chat. Go to page number 29, and here you have all the syllabus, and the same is also pasted in each of these slides. So each of these slides in that order have got these topics. So wherever you feel that it might come in exam, maybe pick up that tomorrow for discussion. Like, I'm not confident that they'll which algorithm did we do? Crystals, right? They might ask us prism also. We never know. We definitely should know prism algorithm. They might ask us Dijktras also, acyclic graph also. They might ask us index mapping. There's no question in the uh, exam paper about hashing, so this is an area of worry. Okay, so coming back, let's finish this off. So let's read this a few times, and then we'll move on to the next slide. uh, let's give a chance to someone else. Malvika, do you want to read this?
Yeah, sure.
Okay.
So yeah, we have sort and merge sort. So
Mm-hmm.
basis of comparison is the partition of elements in the array. For quicksort, it is the splitting of array of elements in an any ratio, not necessarily divided into half. And for merge sort, we have in the merge sort the array is parted into just two halves.
Mm-hmm.
Worst case complexity is O n 2, and this is O n log n.
So that's on
Oh,
square.
O n square. Okay, okay.
Mhm.
um, it works well on smaller area, and merge sort operates fine on any size of array. Speed of
Okay.
execution. uh, Quicksort, it work faster than other sorting algorithms for small data set like selection sort, etc. And for merge sort, it has a consistent speed on any size of data.
Mm-hmm.
Additional storage space requirement, less in place and more not in place. Okay. And efficiency, inefficient for larger arrays, quicksort, and merge sort more efficient for larger arrays. Um, Sorting method, internal. For merge sort, it is external.
Mm-hmm.
Stability, quicksort is not stable, merge sort is stable. Preferred for Quicksort is preferred for arrays, and merge sort is preferred for linked list. Okay. And locality of reference, quicksort good, merge sort poor.
Right. Thanks, Malika. So looks like merge sort is more efficient compared to quick sort, but merge sort takes more space. It requires more additional space. Although it's more efficient, but it needs more space, and it's an external sorting method. Okay. We can probably combine these 2 to 3 points in like one sentence. That will help us remember it. Like, although merge sort is more efficient, it requires more space and for storage compared to the quick sort, and merge sort is external and quick sort is internal. And even though merge sort is more efficient, it is not as stable as, sorry, yeah, it's not only more efficient but also stable, while quick sort isn't. And merge sort is used for linked list, quick sort is used for arrays. Locality of reference is poor. So how I'll try to remember is that merge sort is more efficient and stable compared to the quick sort, but uh, it requires more. additional storage for space requirement, and it has poor locality of reference. So we kind of combining two positives and two negatives. So can someone tell me what are the two positives about merge sort?
It's more efficient and stable,
Correct. And
but
two
it
disadvantages?
requires external. It is external sorting method, so it requires
No,
extra
disadvantage.
space.
What's the disadvantage?
It requires more space.
And last point.
The locality of reference is poor.
Correct. Correct. So let's try to remember this way. So although
What
merge sort is
does
more efficient, sorry.
what does locality of reference mean?
I read that like in the last semester. I've forgotten that. I think locality of reference something to do with if the pointer goes to a particular function and then from there it moves to another function. So the area is called the locality, something like that. I have to refresh my memory. Hold on. Yeah, you might have also studied this. You forgot.
I don't
Principle of
remember.
tendency of processor to access the same set of memory location repetitively over a short period of time. Okay, so let's go with this for now. Access same set of memory location for a particular period of time. That's what the meaning of locality of reference.
So for merge sort it is poor.
Yeah.
I think the
Okay, so
reason for this could be like because merge sort divides the array into two different halves and we create assign new memory to those two halves.
yeah,
So
we
that's
get
why we are
new
accessing
array.
new memory locations every time. Whereas in quicksort, we are doing it in place. In place means that we are not using any extra memory. We are accessing the same memory locations all the time. So that's why the locality of reference is good.
Yes. Great. So two positives are it's efficient, or for the merge sort is efficient, and it consumes. No, it's efficient and stable. And two negatives are it consumes more space, and the locality of reference are is poor. So that way we'll have 4 points already about the comparison of these two. And the fifth point is pretty easy because we just have to write the uh, time complexity, which is O n log n and O n square. And the sixth one will be about how they partition the array. Like in merge sort, they partition into two halves, while the quick sort splits into any ratio, not necessarily into halves. So I think that way 6 7 points will be good enough for us to talk about. So since now we have kind of taken a look at this several times, let's try to recall this without looking. So I want you to give me just 1 point. So I'll start with 1 point and then other people can give me 1 point. So one of the points about quick sort is that when it breaks those elements in the array, it doesn't do it in any specific format, like not in half. It's not fixed that it will break into half, but merge sort breaks the array into half for sorting purposes, n by 2. So Anirudh, give me just 1 point. Maybe
Merge
give me the
sort is
flexible one.
yeah. Quick quick sort is internal sort and merge sort is external sort.
Okay, great. Kritika, give me uh, two advantages of merge sort. Positives.
Two advantages. It can work fine on any size of an array,
Hmm.
and it is more efficient.
Yes, it's more efficient and it is more stable. Okay. So may I give me two disadvantages of merge sort?
A merge sort requires more storage space because
Yes.
it is not in place,
Yes.
and
Locality.
locality of reference is poor.
Yes, correct. See, that way we remembered kind of 6 points, because we kind of put them into one sentence, and it's just the reverse of the other. So merge sort is efficient, it is stable as compared to the other one. So in exam, you can break it into 2 points. And then the disadvantage is that locality of reference is poor and it requires more storage space compared to the quick sort. And the first point was about dividing the array into half, and the other one doesn't do it in a particular manner. Uh, Splitting of array is in any ratio, not necessarily divided into half. Here, arrays part into two halves. This is the time complexity O n square, O n log n, and this is internal, this is external. Awesome. I think you should be good with this.
I think the efficiency point we can modify a little bit. So
How?
quicksort is more efficient for smaller subarrays, smaller data sets, and mergesort is more efficient for larger arrays. So both points are
Oh,
written here, but they are
mhm.
in different points.
Yeah, yeah.
Third and fifth, fourth and sixth.
More efficient for what? For what data set?
So for
Merge sort?
larger subarrays, mergesort is more efficient. For smaller arrays, quicksort is more
We
efficient.
have
For
to
large,
specify the data set there because we're not really saying what type of efficiency, right? So it's good to specify that merge sort is more efficient on the larger data set, correct?
yeah, mergesort is more efficient for larger arrays, and quicksort is more efficient for smaller arrays.
Okay. Advantages of doubly linked list over singly linked list. So just a recap of what they are. So singly linked list is again both are actually linear data structure, and each of single list have got each of the elements is a node which has two parts. One is data, and second is the pointer to the uh, location of the next element. However, in doubly linked list, you not only have data with the pointer to the next element, but you also have the pointer to the previous element. And of course, the last element won't have the next pointer because the next pointer will be null. Advantages of doubly linked list, I think one of them I can recall is it makes it easier for you to reverse the array. Why? Because you just have to swap the positions of the previous and next pointers and move the head to the rear, and that helps you with the reversing the elements. Can someone remember another advantage of doubly linked list? I think insertion is also easy, probably. You don't need to hold it in temp, I believe, unlike single.
Insertion before a given node is easier.
Okay, okay. Because you don't need to know the previous element. You don't need to use a temp to hold the previous value. Because and I think deletion is also easier because if you delete it, you don't need to create a temp. The element remaining already has. Okay, let's see. I'm not 100% sure. It allows traversing in both forward and backward direction because of the next and previous pointers, unlike single linked list, which allows traversing only in one direction. And deletion of nodes is easier compared to single linked list. This is because delete a node, we need to access a node to be deleted and the node previous to it. So in single list for deletion require two pointers, while in double linked list there's no need to maintain an extra pointer as node itself carries the information of the previous node. So they're saying that for deletion in single linked list you need two pointers, but in a doubly you don't need two pointers, you just need one. Reversing a doubly linked list is also easy. We only need to swap each node's next and previous pointers, update the head node to point to the last node to reverse the doubly linked list. We can easily insert a new node before a given node. This is what I think Samaya you said this point. You can insert a new node before a given node. Okay, I want somebody to just recap this and then we can move on.
We basically have insertion, deletion, and reversing,
Yeah,
right?
traversing also. Traversing also. The first point is traversing.
Okay. Right. Okay. So insertion is easy because the tool because it contains both the data and the element, the pointers on both sides. So
Yeah.
which is why it is easy to insert.
Mhm.
Um, the similar reason why it is easy to delete as well,
Yeah.
because
One point to delete you have to remember is that in singly linked list you have to create two temps, and here you have to create only one temp because of it having both backward and forward information.
okay.
Okay, carry on.
Okay. No need to contain an extra pointer. Okay. And the third one is a reversal. Reversal of the link is easy because we can simply just swap each nodes, which is not possible in single list because they have like only two and not they just have the pointer and the data, unlike a doubly list because we can just swap it.
Yes, and tell me about traversing also.
Tell me about
Traverse. The first
reversing.
point.
Okay, so for it to move forward or in a backward direction, unlike a single linked list which only allows traversing in one direction.
Yeah, so you can move in both directions basically. Yeah. So I'm putting to make it easier to remember in exam, putting the topic here, the traversing.
Insertion, deletion, and reversal.
Insertion. So, Kritika, just go ahead and add that now. I'll not spend time here. Just go ahead and add that right now. You have the access, right? Yeah. So now, Anirudh, can you take us through some of the algorithms that you prepared? I'll stop the share.
Uh, should we take a little break? I can do that. Like
Yeah. Let's do
five,
that.
ten
So,
minutes break.
shall we meet at like 7:30? Half an hour sounds good, or you need more time?
Yeah. 7:30 is fine.
Okay, excellent. We'll meet you in half an hour.
Okay. Okay. See you.